Assalamu alaikum. So today we will start our third lecture of advanced quantum physics, in which we will explore the classical view of particle and wave and quantum view of particle and wave. So let us start with the classical view of particle and wave. In classically, you just need one parameter to discover all the things of some particle. Like particle needs just one parameter like position to explore all the things. Like this is a pen, this is my classical pen, and if I know the position of this pen, I will tell the each and everything. If I know the position of this pen on 10-meter distance, so I can find their velocity, I can find its acceleration, I can find retardation and each and everything by taking derivative, integration and all other aspects. Classically, I need just one parameter like position of some particle. If I know, so I will find each and everything about that particle, means I'm deterministic. Okay, but not quantum mechanically. I already told you quantum mechanics is not deterministic, it's probabilistic. Okay, so like suppose a classical wave that a exponential power minus iota x. Minus iota x is the power it tells us about the phase of my classical particle, means direction, and here coefficient a is basically the amplitude of my wave, means high amplitude has high peak, low amplitude has low peak. So this is basically classical view of a particle. Like we just need a simple position. Particle needs just one parameter, position. If you are using wave, so wave needs just two parameters, amplitude and phase. Okay, if you know the amplitude of classical wave and if you know the phase, you will tell us each and everything of that classical particle. Now move towards the quantum view. This is an interesting. So microscopic system, neither pure particle nor pure waves. So microscopic system, what is micro? Micro means small, and you know small system is basically quantum systems. So we are telling us about quantum systems. So microscopic system means quantum system, neither pure particle nor pure wave. So there are two things, one is contradictory, one is complementary. We will discuss two things. So quantum mechanics is complementary, not contradictory. Okay, if the wave and particle aspects of radiation and matter are complementary. We will solve this with an example how complementary, not contradictory, rather than contradictory. What is contradictory and what is complementary? It's very important concept. So light is basically a complementary principle. Light is basically a complementary principle, not contradictory. Okay, so what is this? We will discuss. So light has a wave model. We already discovered that light behaves like a wave and light also behaves like a particle. So now move towards the main thing, which is contradictory and what is complementary. Suppose two persons, A and B. Okay, A are seeing towards this box, B are seeing towards this box. One is saying this box is hollow in shape. The other one is saying this box is solid in shape. How that possible? This is a box and this box is a particle, and this is only and only one box. There is no such two or more boxes. There is only one box. But one is saying this is solid in shape, the other one is saying hollow in shape. How that possible? There must be one person who is true, the other one must be wrong. Because there is only one particle and the shape must be only one, because this is a classical particle. Classical particle not changes its position or shape, either anything. So either B is correct, either A is correct. Neither both is correct. So one must be true, either A or B. Both must not be true. This is basically contradictory, means there is contradiction between both. Either A is correct, either B is correct. But only one should be correct, not both, because both box has only one shape, either solid or hollow. So this is basically contradictory law. So light is not contradictory. Understood? Light is complementary. What is complementary? Here one is wrong, one is right. But what happens in complementary? Suppose again two persons, A, B. A is right side of this cylinder and B is upside the cylinder. B is upside the cylinder, suppose here, and A is right side of the cylinder. So what both says? Suppose person A says that this cylinder has a height h. Yes, we are seeing this cylinder has a height h. Look, this person is telling us correct. But the other person says The other person says, circle has a radius of r. He says, cylinder has a height of h. He says, circle has a radius of r. How that possible? Yes, this is possible because both are watching this cylinder from different aspects. This is watching from this side and this is watching from upside. He saw this cylinder as circular in shape with a radius r, and right side person watched this cylinder as their side with a height h. So both are correct. The only reason is they are watching this cylinder from their own aspects. Their reference is different, but they both are telling correct. So if you are changing your reference, you are telling us correct, but it don't mean you are wrong. So here both are correct. So this is basically complementary principle. So light behaves like a complementary. Means if you are watching light from other aspects, it behaves like a particle. If you are watching light from other aspects, it behaves like a wave. So here light is behave like both dual nature. So light is the same thing as complementary principle. So light behaves like same, so all are both. So basically light means waves and particles behave like complementary, not contradictory. So now move towards the next thing, which is intensity of classical particle. If you want to find the intensity of classical particle, you just have to take the probability mean psi square. If psi is the wave function of my quantum particle, so if you want to find intensity, you just have to take the probability mean psi square, psi mod square. Okay. So classically psi 1 square equals to psi 2 psi square becomes equals to psi 1 square plus psi 2 square if there are two wave functions. Classically what you have to do, suppose classically you have two waves. This is my one wave, suppose this is my one wave, and suppose other wave also like this. Okay, so classically if you want to find the resultant wave, you just have to add both waves. If there are two waves like psi 1 square and psi 2 square means their intensity. If you want to find the total intensity psi square, so you just have to sum up. This sum up is also called superposition principle. Okay, so psi becomes, this is for classical particle, you just have to add both. But what about quantum particle? You have to take square of your psi, but here psi square means psi conjugate, psi star. This psi star means you have to take the conjugate of this psi. Okay, this psi square now becomes equals to psi star. So if you want, there are two waves, they both have different wave functions, psi 1 and psi 2 suppose. So if you want to find the superposition, so you just have to see like psi square becomes equals to psi 1 plus psi 2, psi 1 psi 2, here also psi 2 psi 1 star plus psi 2 star. How this becomes, you just have to multiply the both values of psi 1 and psi 2. Let's suppose psi 1 becomes equals to psi 1 star and psi 2 equals to psi 2 star. Just multiply, you will get this expression simply. Okay, so here you see I just put the values if you want to find the superposition, because you know in superposition you just have to add up all the waves. Suppose if there are two waves, so you have to add them both. Put the value psi 1 and psi 1 star for psi 2 star. So this is basically known as quantum interference. Okay, so the next thing is Heisenberg uncertainty principle. Quantum mechanics, particles are not localized. I already told you, you are not deterministic. You cannot localize quantum particle, it always in space. So we cannot measure position and momentum simultaneously. I already told you that you cannot measure like position and momentum simultaneously in quantum mechanics. If you are finding position, there is uncertainty in momentum. If you are finding momentum, there is uncertainty in position. Because quantum particle is continuously changing their direction. It is not deterministic. You cannot localize quantum particle, so you cannot find momentum and position simultaneously. So next, what the quantum particle have wave function. I already told you that every particle is associated with wave function, so quantum particle is also associated with wave function, means it start emitting what? Waves. Wave function means waves. We only tell about the probability. Quantum mechanics, we know that it is probabilistic, not deterministic. So because it is probabilistic, so it tells us only about the probability of quantum particle. So let us take an example that If a position is delta y, and if the momentum is delta p, the product of this becomes equals to h cut. Okay, so if the position is z and momentum in z direction, always also equals to h cut. If position is in x direction and momentum is also in x direction, also equals to h cut. There is uncertainty in all. If you find the position, there is uncertainty in momentum. Position, there is uncertainty in momentum. If you're finding position, uncertainty in momentum. And always product of both position momentum equals to h cut. Okay, there is also an uncertainty in energy and time. If you are finding energy, there is uncertainty in time. If you are finding time, there is uncertainty in energy. Always equals to h cut. So this is a simple uh, experiment. So let's take an example that position and momentum, you know that equals to h cut. If you want to find the position, if you want to find momentum, take positions to the other side, open the values of momentum, you know m delta v h cut by delta x. So suppose if you are taking for classically h cut value is always 1. Keep in mind, classically h cut value is always 1. So let us solve this first for classical vision, then for quantum vision. So for classical vision, h1 is always equals to 1. So here h cut becomes equals to 1, and let's suppose and this m goes here, so m delta x. So let's suppose mass is 10 grams, means 0.01 kg. So mass is 0.01 kg. And let's suppose your position is 3m, means 3 meter. 3 meter, because we are solving classically, so classically mass is very large, see 10 grams, and distance is also see very large, 10 meters. This is my one. And what's the answer? Velocity you see nearly equals to 33 meter per second. Wrong, not possible. We cannot find this velocity. So now move towards the quantum mechanics. In quantum mechanics, you know what is the value of this h cut? 6.63 into 10 raised to minus 34. So let again put the values. Here we get delta v becomes equals to m goes downside, m delta x. M, which is 10 grams, so 0.01 kg, and position 3 meters, 3. And h cut is replaced by 1.6 into 10 raised to minus 34. Basically, this is the value of h. H cut value is 1.6 into 10 raised to minus 34. So put the values, you will get this answer, 2.2 into 10 raised to minus 34. This is very low velocity. So you can find low velocity in quantum mechanics. So this is correct. Okay, basically h equals to h by 2 pi. If you divide h means Planck's constant with 2 pi, this divided by 2 pi, you will get this relation. Okay. सो लेक्चर 3 में हमारा एक टॉपिक रह गया था, तो आज हमने डिस्कस करना है हेज़नबर्ग मैट्रिक्स थ्योरी, जिसको हम मैट्रिक्स मैकेनिज्म भी कहते हैं, ठीक है, मैट्रिक्स मैकेनिक्स. एंड द सेकंड वन इज श्रोडिंगर वेव थ्योरी. The other name is wave mechanics. Okay, so Heisenberg matrix theory invented in 1925 by Heisenberg. It is the name of the scientist, quantum physicist, and the other one is Schrödinger wave theory. This was also on the name of this physicist Schrödinger. Okay, so it is invented in 1926. So what is basically this? For quantum theory, we need quantum states or wave function for a particle. Okay, so as we are in quantum, we just need quantum state or function for a particle. If we don't have wave function of some particle, we cannot say anything about that quantum particle. So okay, so every quantum particle must associated with a wave. Okay, so we must know how with that wave function of that particle. Okay, so if you know the wave function, we can find anything position of momentum. Okay, so this is the simpler thing. If you just know the wave function of that quantum particle, then you can easily find the position and momentum of your particle. You already know you cannot find position and momentum simultaneously, but if you know the wave function, then you can easily find the position and momentum. Okay, but not simultaneously. This is not happens in quantum physics. Okay, so what is basically wave function? We are telling that every particle must associated with a wave, means wave function. So what is basically this wave function? Wave function describes the quantum state of a particle. It tells us about the quantum state of a particle. Okay, so a wave function describes quantum states. Basically, it is a state of quantum of a particle. It tells only about the quantum state of a particle. It only tells you about the state of quantum particle. Okay, not telling you about the classical. So let us take an example like DNA and wave function. Similarity between DNA and wave function, both are similar. Okay, so basically what is DNA? You already know. It is an information molecule in cell that contains coated at what protein is made up of. Basically DNA contains your information of your all body. this is the building block function of a DNA. What is wave function? It is an information entity in quantum mechanics that contains all information about the physical state. DNA holds the information about human, and wave function is an information entity in quantum mechanics that also holds the information of a physical system. So basically, wave function and DNA, to as an example, both are similar. So if you want to know what is wave function, you can easily explore wave function with an example, like you can compare your wave function with a DNA. Both have same working. Okay, the working principle of a DNA and a wave function both are same. So if you want to find the probability density, you just have to take mod square. Means if you have to find the probability of psi, then you have to take psi square. Okay, psi square must equals, if psi of xt means time dependent wave function probability is 0, then there is no particle. What it means if your probability is 0, means the thing is not exist there. Understood? So the pen is on page. Okay, so there is probability that pen is either on page. Classically the pen is there. Okay, but if pen is not there, so their probability must be 0. So if probability is 0, you can say the particle is not there. If probability is 1, then you can say perfectly the particle is there. Understood? So also the normalization, if you are taking mod square of your wave function and integrate it from minus infinity to plus infinity whole interval, you will get your wave function normalize equals to 1. This is the condition of normalization. If you want to normalize your wave function, you have to take the probability, then integrate from minus infinity to plus infinity and becomes equals to 1. Then you can easily normalize your wave function. Understood? So these are our some topics. Now the important thing are two things, that are vector space and Hilbert space. So what is basically vector space? Vector space is a classical space. You already know we have x, y, z directions. Okay, if you want to find the direction, so x of I, j, y of j, and z of k. This is the direction of your position. Vector means vector space in classical physics, in classical mechanics. So if you want to find the magnitude of your vector r, so you just have to sum up all taking square and have to take under root, then this is your magnitude. So this is basically classical method of finding the vector space. These are some substituents, that iota dot iota becomes equals to 1, j dot j becomes equals to 1, k dot k becomes equals to 1. But opposite ij, jk and ki becomes equals to 0, not equals to 0, not equals to 1. Okay. So our last topic of lecture number 3 is Hilbert space. What is Hilbert space? Basically, vector space is a limited space that you are in 3 dimension, mean 3D, means x, y, z. But what is basically Hilbert space? Hilbert space is a n dimensional space, means there are n dimension, there are n coordinates, there are no limit of coordinates, there are n number of coordinates. Okay, so if there are n number of coordinates, you are in Hilbert space. The space deals with a function. Okay, for example psi. So let us take psi of x as a wave function. It has an n dimensional space. If your wave function has an n dimensional space, then you can say that your wave function is in Hilbert space. Okay, a wave function can be expanded as a linear function combination. Okay, or it is linearly distributed, like say this is a particle, this is an x-axis, y, this is n number of, okay, 1 2 3 4, 1 2 3 4, and this is n number of dimensions, then you can say you are in Hilbert space. Okay, so if you want to find that psi of x, then you just have to sum up all your wave functions. So for 1, for 2, for 3, okay, and so 4. Similarly, you just have to multiply it by constants, first a1, second a2, and third a3, and so on. Okay, so I already told you that if you want to find, so just you have to integrate from minus infinity to infinity. One is psi of n, the other one is the conjugate psi of m star. Okay, this is equals to delta mn. Okay, this is the main formula. If m equals to n, means both are same. If m equals to n, then the states are orthonormal states, and your answer must equals to 1. The answer of this must equals to 1. If m is not equal to 1 and both are different, then must equals to 0. This is called orthogonal states. If m equals to n, orthonormal states; m not equals to n, orthogonal states. So this is the main formula. We have to integrate psi of n and the psi of other, means one is psi of n, the other one is psi of m, and the other one is the conjugate of first. So this is here. and the sum and the probability of the constant u which you take a1, a2, a3 and a must equals to 1. Hilbert space is an n-dimensional space. As I already told you, in n-dimensional space a function psi can be expressed as a linear combination. Already we discussed above. Okay, similar things. If psi and phi are vectors of space, then sum will be also a vector space. Hold commutative property. This also holds commutative property. How? You see, if psi is one wave function and phi is the other vector of space, then you have to sum up all in vector space. Okay, psi is one wave function, phi is other wave function, so this must be equals to phi plus psi. What it means? It means both wave functions obey commutative law. Okay, so that's all for today. For next lecture, lecture number 4, we will start with Dirac notations.